Many times we say VPN, and most of the time we mean security VPN. Even those people who are not in IT use this term VPN, virtual private network. All that they mean is a secured connection. They really don't understand this word tunnel when you say VPN. Tunnel is a word what the technical people use. Tunnel, we only use that word tunnel. Even I am not ready to accept the word tunnel, but that is what mostly people use to say VPN. In the IT world, we say tunnel. You see, these two round indicates two edge router of an ISP. They call it as provider edge because this edge is going to connect to the customer edge. I got provider edge 1 and provider edge 2. Why provider edge? As I told you just now, it connects to the customer. We got some customers, brown and purple customer. Brown and purple customer. Now they are given a dedicated wire. Provider has given them dedicated wire. Let's call it as G0, G1. G0, G1. Let's say this one is the head office of Brown, the branch office of Brown. This is the branch office of Purple, head office of Purple. They want a private connection between the sites, and they got private network also. They have a private network, let's say 10.0.0.0/24. On the other side, 10.1.1/24. Knowingly or unknowingly, this customer also have got same 10.1.1.0/24, 10.0.0.0/24. Now they both are going to use a common shared internet. A common shared internet via ISP. Now ISP has got very big backbone core network with multiple paths between this PE. All these rounds are routers. Fully mesh topology. ISP have got full mesh topology. All are connected to all other routers. Something like this. If you notice here, there are multiple paths to reach between provider edge 1 and provider edge 2. Regardless of the physical path, I want a connection between these two. We call this as VPN. Why do I need this VPN? Why do I need a direct connection between provider edge 1 and provider edge 2? It's not a physical connection, but it is direct connection. Why do I need this connection? How do we get this connection? We'll discuss later. I want to just say first why we need this. I want a direct connection between PE1 and PE2, but I cannot put a physical wire, or I don't have the option. I want a connection. So I decided to form a virtual connection between PE1 and PE2. Now, the first question that I want you to know is, why do we need this? See, the customers are advertising their routes, and this router will be learning it. We don't want customers' route to be learned on all these routers. We don't want. We don't want any of this core router to know the networks of customer. We don't want the routing table to process it. We don't want the routing table to have the updates of 10 network. We don't want customers' route to be inside providers' routers routing table. The other reason is here also I have some 10 network. So I don't want those two to get mixed. For that, what I do is whatever you learn from the customer on PE1 router, throw it directly to PE2. For that, PE1 and PE2 should have some sort of connection. P1 should throw it directly to PE2 so that none of these routers need to learn it in the routing table. And if this head office wants to talk to branch office, the packet will be placed inside this virtual connection and go to the other end, and this will take it from the virtual connection, put it in the physical connection, and deliver it here. This is what I want. For that, I need a connection between PE1 and PE2, and that I want it as a virtual connection. We call it as VPN. This looks like a tunnel. So we used to call this word tunnel. VPN means tunnel. For the non-technical people, VPN means secured path. For a technical people, VPN means tunnel. What it is in reality, it is not a tunnel. And it is not a secured connection also. Then what it is? It is encapsulation. VPN is an encapsulation. Encapsulation of what? Encapsulation of additional identity which will move the packet between this PE1 and PE2. Listen, I just told I don't want this router to learn about customer's route. So customer is talking from 10.1.1.50 to 10.0.0.0.10. I'll call this as computer B, computer A. So what will be the source IP address if A is talking to B? What will be the source IP address? 10.1.1.50. Destination will be 10.0.0.10. Now, when this packet approaches here with a source of 10.1.1.50, destination of 10.0.0.10. An additional layer of encapsulation happens, which is going to have the IP address of this router, let's say 1.1.1.1, IP address of this router 2.2.2.2. Source will be 1.1.1.1, destination will be 2.2. So this layer getting encapsulated, additionally added, so that when the packet moves to the next router will read this destination only. When it reads the top destination, it understands the packet should go to 222, 222, 222, delivered to 222. See, the packet with the original source and destination, which is not routable here, these routers don't have route of customers. But the packet is moving. Though the source and destination, original destination is unknown to these routers, still the packet moves from PE1 to PE2 because of this additional layer of source and destination. We call this as encapsulation because you added new layer, encapsulated with a new layer. Fine. After reaching the other end, PE2 knows that there is a new layer added and the layer is having destination 222, so I have to remove this upper layer and read the inner layer. So it removes this layer because it is 2222 and reads the next layer destination and delivers the traffic down here. So I have explained to you so far why and how. Why I don't want customers route to be learned on all the inside autonomous system routers of ISP. Then how you will move the customer packet from one end of the provider edge to another end of the provider edge with an additional layer of source and destination which provider knows. An additional layer of source and destination which the provider knows is what we encapsulate so the packet can move from this end to that end. This is what we call as VPN, encapsulation. When someone calls this as VPN tunnel, I don't agree. No one will agree if they know the working principle of this. Tunnel is nothing but encapsulation only. There is no tunnel. There is no tunnel actually. There is a virtual connection established between PE1 and PE2. If you say like that, that is more technical. Because of your encapsulation of additional layer, a virtual connection and a new session between PE1 and PE2 comes up. Now, who will negotiate this virtual session? Or in another simple technical term, tunnel. Who will negotiate this tunnel? There is a protocol called GRE, Generic Routing Encapsulation. But we don't need that one. Today we are in a BGP MPLS Layer 3 VPN class. So in BGP MPLS Layer 3 VPN, who negotiates this tunnel? BGP only. We call this as Mpbgp tunnel, or we can call it as Mpbgp circuit, or we can call it as Mpbgp feature, multi-protocol, border gateway protocol. Now, BGP has got various service in it. BGP is not only a routing protocol. Along with this, it provides various other services. That's why we call this multi-protocol. It is not only a routing protocol, it is also a protocol which can negotiate VPN, which can negotiate a virtual session with a remote router. See, between PE1 and PE2, we want a virtual connection. We want a VPN. We want a tunnel. So what we do is we use the IBGP feature. IBGP is a BGP within an autonomous system that can form neighbor with a remote router. PE1 and PE2 are remote routers. They can form neighbor because BGP is a TCP protocol. So as BGP is a TCP protocol, it goes and negotiates a virtual circuit, a tunnel with the remote router. PE1 and PE2, they bring this tunnel up with the help of BGP. We call it as layer 3 VPN. Why layer 3 VPN? Because we are going to use labels inside this tunnel, or we are going to use the label to identify the circuit endpoints which are provided by MPLS for every single layer 3 destination. We learned about MPLS in the previous class. We saw a label is assigned to every single destination. So when you have a virtual circuit, for these destinations also there will be a label advertised via this virtual circuit. Now those virtual circuit runs LDP, same like a physical circuit, to distribute the labels. Via this virtual circuit, via this tunnel, via this VPN, the labels for customer network is advertised. Whereas via the physical network, labels for provider network is advertised. You see, if I want to ping from A to B, I need a label to identify B, which is provided by this PE2 via the circuit to PE1. So now when a packet comes, PE1 is going to use the label given by PE2 to reach B, to reach B, 10.0.0.0. But in order to go from PE1 to PE2, the local label is needed. So using the local label, traffic moves from PE1 to PE2, which is the upper layer of the MPLS. And there is another layer, bottom layer of MPLS, which is read only by this guy. See, here earlier we had two layers of IP. Two layers of IP. This time we have two layers of labels. Earlier we had this one. That is normal layer 3 VPN. This is Mpbgp. This is MPLS layer 3 VPN. So what I am trying to say is the original source IP address is going to be same. Destination also will be same. But you're going to have two layers of MPLS. The inner layer is talking about the label given by P2 to identify this B. Let's say label number 100. The upper layer is going to have the label to move the packet from this place to this place, and then this place to this place, this place. So let's say that is label number 30. So when the packet goes here, this guy knows what is 30. 30 means 2.2.2.2. So he puts the label given by this router. Let's say that is 40. It goes from here to here, and then here to here, and then PHP. And then this guy knows what is label number 100. He removes the label and pushes the packet down here. That is Mpbgp or MPLS layer 3 VPN. It's not a normal layer 3 VPN like GRE. It is MP, multi-protocol BGP, which is using LDP labels to identify the VPN and to identify the next hop inside the core. We call this as transport VPN, transport label. Transport label. We call this as VPN label or service label. You see, with the additional encapsulation, like you routed the customer traffic using IP address, now you are routing the traffic using MPLS label. Your original source and destination IP address is not changed. That is still there. And altered. Additionally, new two encapsulation, one for normal routing inside the service provider core, another one for the VPN tunnel endpoint. You remember, David, I was talking about the bottom of a stack. Tell me on which one the bottom of a stack will be one. Is it service label or transport label? After EXP, there will be one bit called bottom of stack. Which way, where it will be one. One means that is the last layer of MPLS. Bottom of the stack. For which it will be one, for which it will be zero. Will it be zero for transport or will it be zero for service? Will it be one for service or will it be one for transport? Very good. That is the last label that will be put. This will be keep on changing and it will be popped off again in this place. Very correct. This will be having zero. Very correct. Nice. So far what we saw is how MPLS layer 3 VPN with the help of BGP is used to move the packet of customer as it enters into PE1 towards PE2 out via PE2 to final destination B. There is also another part of this layer 3 VPN that we should know. What is that? This part. So far you have finished this part, the core part. Now we need to understand this portion of these two routers. When I say this portion, I mean this portion. The customer facing PE we have to learn something there. There's a VPN ready to carry the customer's route. But now, which route will be placed inside this VPN? You see, the VPN should be used only for the customer's route, customer's network. So there is a need for a separation between customer's network and the provider's core network. provider, you see, for every single hop, there is one network. Here one network, here another network. So we run some IGP protocol like ISIS. Those ISIS learned routes that is there in this routing table of PE1 and PE2 should be isolated from the customer's route that is coming from outside. For that, what we do is we create a virtual router inside called VPN instance. That is what the common term. Cisco, Juniper calls it as VRF. Huawei, Ciena, they don't call it as VRF, they call it as VPN instance. There's also another name actually for this. Nokia, Ciena, they're all calling